Hello everybody and welcome back to another video. In today's video I want to go ahead and talk about the domain and range. Specifically, we're going to be discussing what they are, and then we're going to go over a couple of examples so you can look at a couple different methods for solving them. This video is more oriented to learning what they are than actually solving difficult problems. So let's go ahead and dive right into it. Simply put, the domain and range are characteristics unique to every function that tell us what values that function spans. And a lot of the time, especially when you're first learning about functions, you're going to see this little box analogy where we start with an x that we then input into our function, our machine, and then we get some sort of value out, which is our y. The domain is all the allowable inputs that we can put into this box or this machine, while the range is all of the values that we're going to get out of the machine if we put every single input into it. To better illustrate this, let's look at a couple of graphs and see exactly what this looks like. Let's go ahead and start with the most simple function we can. F of x equals x. We're going to draw a simple little graph here. It's nothing special, it's just quick. And then we're going to plot our function on our graph. Okay, so we can notice a couple of things immediately. All of our x values are covered. We can input any value we want into this function and get some sort of output. So the domain is going to span every single real number, and a lot of the times you'll see this notation where we'll have like domain or d, and then we'll have parenthesis, negative infinity, comma, infinity. And all this is telling us is the x goes all the way from negative infinity to positive infinity. We have no restrictions on our x at all. And since our y and our x are identical, that also means that our range is also going to span from negative infinity to positive infinity. And note the parentheses here that we're using. When the function doesn't reach that number, we're going to use parentheses, whereas if the function does reach that number, it does contain that number, we're going to use brackets instead. And infinity is kind of a special case. Infinity isn't a real number, it's just a construct to tell us that this never ends. It keeps going forever. So that's why we always use parentheses with infinity, whether that is positive or negative. Another way of saying this that you might recall from a basic physics class or science class or algebra class is x is our independent variable, while y is our dependent variable. So x is going to be all of the things on the x-axis, or our domain, while y is all the things here on our y-axis, or our range. Let's look at two more functions to help kind of solidify these concepts a little bit better. I won't get rid of the graph all the way. The first function is going to be f of x equals x squared. You'll see a lot of exponent functions, so it's kind of good to get a grasp around them and what their domain and range are. So for this example, we're going to kind of think through it before we just graph it. X squared means we have whatever number, x, times itself, x. So that means if we were to have 2 squared, it'd be 2 times 2. And if we were to have negative 2 squared, it would be negative 2 times negative 2. And hopefully you can kind of see a little bit that that means we can never have a negative value. We're just going to hit 0. Like if we're coming down this way, we're going to hit 0 and we're just going to pop right back up. And this is what our graph would look like. This tells us that no number in the range can be negative. So even though we can have negative inputs, we can never have a negative output. So while the domain is going to be negative infinity to positive infinity, notice we're spanning this entire x-axis here. The range is only going to be from 0 to positive infinity. And notice the bracket here, because 0 squared is equal to 0. That's why we have the bracket. The 0 is included in the range, but no negative numbers are. Let's go ahead and get rid of this and look at one more final example to hopefully help you guys out a little bit here. This final example is going to be a little bit more difficult, but I think you guys will be fine. F of x is equal to the natural log of x. This specific function is a little bit different. First, let's go ahead and I'm just going to explain this a little bit. This is actually the inverse of e to the x. And if you know the domain and range of e to the x, that can kind of help you out a little bit here. I'm not going to show that, but just keep in mind you can do it that way as well to help think through some of these problems. So the natural log of x is a little bit different because we actually have an asymptote right here at 0. That's kind of a bad color. Hopefully you can see it. I'll use something like this instead. We have an asymptote at 0, x equals 0. But the function's actually going to look something like this. And this is 1 right here where it crosses. So automatically we can see immediately that the range is going to span from negative infinity all the way to positive infinity. Even though this is a really slow growth towards positive infinity, it's still increasing. Even if it takes a long time to get to infinity, or what we would consider infinity, it's still growing. So just keep that in mind. As long as it's growing, it's going to hit infinity eventually. Even if it doesn't hit it quite as fast as something going like that. Now, the domain. So our domain is stopped right at x equals 0, but it continues on in the positive x direction indefinitely. So the domain is going to be 0 to positive infinity. And notice I put a parenthesis here. That's because our asymptote our function never actually touches this asymptote. It will just run along it until it gets infinitely close, but it never actually touches 0. So I hope you guys enjoyed this video. I hope you took a couple things away about the domain and the range, and hopefully have a better understanding of these concepts now. If you did enjoy this video, make sure to leave a thumbs up and a subscribe. Check out some of the other videos I've created on the channel, and I'll see you guys in the next one. Thanks, bye.